Today we're going to talk about variation. By the end of this video, you should be able to write the equations of direct, inverse, and joint variation, and you should be able to use these equations to find other values, including real-life situations. You should have learned about direct and inverse variation in Algebra 1. We're going to add joint variation, and we're going to answer some more complicated problems. First, we need to take a look at some vocabulary. The constant of variation, or the constant of proportionality, you could see it written either way, is represented by the letter K in each of the formulas that we will see below. This should be the first thing you find for every single problem. For direct variation, we use the formula y equals k times x. In a problem, you will see the phrase y varies directly with x, or y varies directly as x. If you see a phrase similar to that, you'll know that it is a direct variation problem. For inverse variation, we use the equation y equals k divided by x. This would be represented by the phrase y varies inversely with x. And the new type of problem is joint variation. This is represented by the equation z equals k times x times y. So we have an extra variable in this problem, and that's represented by the phrase z varies jointly with x and y. So you need to look for these key phrases as we do each of the problems. So first we're going to take a look at a couple of real-life examples and figure out which type of variation they are. First, we have points for a touchdown in football. So if we're looking at how many touchdowns do you score and how many points do you earn, that is direct variation. As one variable increases, the other variable increases. So the more touchdowns you score, the more points you earn. Next, we have the price of a movie ticket versus how many people go see that movie. So we're comparing how much the ticket costs and how many people actually go see the movie. This would be an example of inverse variation. If the ticket is too expensive, fewer people are going to go see the movie. So as the ticket price increases, the attendance would decrease. But if the ticket price decreases or the ticket gets cheaper, generally the attendance will increase. People will be more likely to go see that movie. And lastly, we have refreshment income for the number of stands, the number of people, and the price of $2 per hot dog. So if we're talking about a baseball game and you want to figure out how much money they make from selling refreshments, they would need to take into consideration the size of the ballpark or the number of stands, the number of people that are in each section or the number of people that are in attendance, and in this case, the price of a hot dog is $2. This is an example of joint variation. The refreshment income depends on a couple variables. It depends on the size of the ballpark, the percentage of seats that are filled, and the cost of the food. So, what would K be for points for a touchdown in football? So if we go back to this first example, and we're looking at how many touchdowns do you score and how many points do you earn from those touchdowns. K, or the constant of variation, would be the number of points that you earn for each touchdown. So for the act of getting in the end zone, you earn 6 points. Whether you kick the extra point or go for the 2-point conversion would be a separate calculation. But each time you get in the end zone, you score 6 points. Let's look at a couple of examples here. We want to write the equation for each variation described. Pay attention to your variables. So even though the formulas use x and y and z, you can be given a question with any variable. The first one says w varies directly with the cube of m. So we have a couple keywords here. Directly. That tells us that we're going to use the formula y equals kx. The fact that we have w varies means we're going to have w equals. And then we need to pay attention to the cube of m. That means m cubed. So when we write out this formula, we're going to have w varies, or w equals k times the cube of m. You will always have k in every single formula. Let's look at the next one. Q varies jointly with A and B. So jointly tells us that we're going to be using the formula z equals kxy. Q varies tells us we're going to have q equals, and then A and B are our other variables. So our formula is going to be q equals k times A times B. Now, C is a little bit more complicated. Z varies directly with x and inversely with the product of w and y. So we have direct variation and inverse variation in the same problem. We know it says z varies, so we're going to have z equals. Remember that directly means k times x, and inversely means k divided by x. So if z varies directly with x, that means we're going to have k times x, and then z varies inversely with the product of w and y. That means w times y. So if it varies inversely with wy, we're going to divide by wy. Problem number 3 says, if y varies directly as x and y equals 12 when x equals 15, find x when y equals 21. So first we need to write our equation. We have y varies directly. So we have y equals k times x. We know that y equals 12 when x equals 15. So let's plug that in. So we can solve for k. We just need to divide both sides by 15, and we get that k equals 4/5. So now we can write our equation of variation, which would be y equals 4/5 x. This is our equation of variation. And then the last thing we want to do is find x when y is 21. So now I'm going to plug in 21. And I need to solve for x. So I'm going to divide both sides by 4/5, or multiply both sides by 5/4. And I end up with x equals 26.25. So that is my final answer for this problem. Number 4 says, if g is inversely proportional to the square of m, and g equals 3 when m equals 4, find g when m equals 6. When you're doing these problems, make sure that you stop at each comma in the problem. Generally, each phrase gives you enough information to do one step of the problem. So we have if g is inversely proportional to the square of m, or if g varies inversely with the square of m. It's the same thing. We know that this is inversely proportional, so we're going to have k divided by x. We have g is, so we know we have g equals the square of m is m squared. So we're going to have g equals k divided by m squared. Then read to the next comma. G equals 3 when m equals 4. So we can plug that in. And we need to solve for k. So 4 squared is 16. Then we need to multiply both sides by 16, and we end up with k equals 48. So we can write out our equation of variation. We have g equals 48 divided by m squared. Then we can go on to the last phrase. It says find g when m equals 6. So we want to plug in 6 for m. And then we can just type this in our calculator. 48 divided by 6 squared gives us 4/3. So g equals 4/3. Let's move on to some word problems. In a certain manufacturing process, the cost of producing a single item varies inversely as the square of the number of items produced. If 100 items are produced, each costs $2. Find the cost per item if 400 items are produced. So again, let's read the first sentence and try to write our equation from that. In a certain manufacturing process, the cost of producing a single item varies inversely. So the cost, or I'm going to use the variable c, varies. That means I'm going to have c equals And it says inversely, so I know I'm going to have k divided by x. It varies inversely as the square of the number of items produced. So I'm going to use n squared. The next sentence says, if 100 items are produced, each costs $2. So if 100 items are produced, each costs $2. So the cost is 2. The number of items produced is 100. So I need to figure out what k is. So 100 squared is 10,000. And then if I multiply both sides by 10,000, I end up with k equals 20,000. So I can write out my equation of variation. Then I can read the last sentence. Find the cost per item if 400 items are produced. So I'm going to plug 400 in for n. Then I can just type this in my calculator. And I end up with 0.125. Now, since this is a word problem, I need units. So you can either write this as $0.125 or 12.5 cents. Let's look at one more problem. The number of vibrations per second, or the pitch, of steel guitar string varies directly as the square root of the tension and inversely as the length of the string. If the number of vibrations per second is 5 when the tension is 225 kilograms and the length is 0.6 meters, find the number of vibrations per second when the tension is 196 kilograms and the length is 0.65 meters. So that's a lot of information. But again, we want to look at it one sentence at a time. The number of vibrations per second, or the pitch of a steel guitar string, vary directly as the square root of the tension and inversely as the length of the string. It says the number of vibrations varies. So that means I'm going to have, I'll do V equals. Varies directly with the square root of the tension. So that's going to be square root of t. It says directly, so I need to have k times square root of t. And inversely with the length of the string. So I'm going to use L for that. Okay, next sentence. If the number of vibrations per second is 5, so vibrations is 5, when the tension is 225, and the length is 0.6 meters. So let's find out what k is. We can start by multiplying both sides by 0.6. So I end up with 3 equals k times, and then the square root of 225 is 15. So then if I divide both sides by 15, I end up with k equals 1/5. Or if you prefer to write it as a decimal, you could say it's 0.2. So let's write out our equation of variation. going to go ahead and write this as a decimal. Then I'm going to read the last part of the problem. Find the number of vibrations per second when the tension is 196 and the length is 0.65. So we want to find the number of vibrations when the tension is 196 and the length is 0.65. So we can go ahead and type that in the calculator, and we end up with, I'm going to round it to 3 decimal places, 4.308. Then we need to check and see what our units are. Earlier in the problem, the number of vibrations per second is the unit that's used. So that will be our final answer.